This is a neat remote switch that can be used in a 12-volt vehicle system to connect and disconnect the battery completely. Because I don't want to cut power completely, I've actually used it as a remote switch to replace the toggle switch of this drop-in kill switch kit. Now, instead of cutting complete power to the battery, it just disconnects and connects the starter relay. In this video, find out how it works, plus some interesting things to know before getting one. I will also test how much power it uses from the battery when turned on and when turned off, so that I know how much power it will drain from the battery it is connected to. I've actually seen two versions of this, so if you're considering to get one, watch on to find out what to know before buying and which one to get. Frakking Creations, showing you the good stuff. Please pause to read. This video is for educational and entertainment purposes only. At a high level, this is basically a big relay switch with a wireless controller added to it. There are two systems in this remote relay: a wireless controller that controls an electromagnetic switch, and a second circuit that is opened and closed by the electromagnetic switch. Pins 85 and 86 are to power the wireless controller that controls the electromagnetic switch. The electromagnetic switch controls the opening and closing of the secondary circuit that is connected to terminals 30 and 87. Normally, pin 85 will be connected to the battery's negative terminal, and pin 86 will be connected to the positive terminal. This will power the wireless controller. Typically, this remote relay is supposed to be used to connect and disconnect the battery it is connected to, and pin 30 and terminal 85 are supposed to be connected to the negative of the battery. In this model, pin 85 was removed. Instead of having another wire for the user to connect to the same location, the manufacturer decided to connect terminal 85 to pin 30 internally. This is why this version of the remote switch has only one spade terminal for the positive connection, while the negative spade terminal for pin 85 was removed. To install and use, always disconnect the battery negative terminal first and reference their official documentation for safety. To use this as a battery disconnect switch, I get all the connectors attached. A test fit might be needed to be done before all nuts are tightened properly. Then I connect the pin 86 positive cable of the remote switch to the positive terminal of the battery. Then connect the vehicle's negative cable terminal to terminal 87 of the remote switch. And then connect terminal 30 of the remote switch to the negative battery terminal. Connecting to the battery's negative terminal is always the last step for safety reasons. Note that I believe there is a mistake on the printed diagram on the remote relay. On here, it looks like pin 85 is supposed to be connected to the positive of the battery, but based on their own online diagrams and how it is wired internally, pin 86 should be the one connected to the positive of the battery. I have seen different models of these remote switches, and they come wired differently, so make sure to always double check with the official documentation. This battery disconnect setup allows easy remote disconnecting and connecting of the 12-volt battery that the remote switch is connected to. Some people use it as a kill switch to prevent car theft, but I think that isn't the greatest idea because it cuts power off completely. With power cut completely, some vehicles will lose memory settings, and vehicle clocks will have to be set every time the power is restored. Plus, if the vehicle has an alarm system or dash cam with parking mode, they will not be working when the power is cut. Instead, I use this remote switch differently. I use it to replace the toggle switch that is used to control this starter kill switch. This way, I don't lose vehicle power while still being able to prevent the vehicle from starting without first turning the kill switch on, wirelessly. Find out more on this remote kill switch install and the plug-and-play kit used in our 2 DIY videos here. An important point to note is that this remote relay is normally meant to be installed between a battery's negative terminal in order to disconnect and connect it. This means it is supposed to be able to handle a high current. In this case, this model is rated up to 250 amps. That's why it has the heavy-duty copper connector plates, heavy-duty copper terminals, huge internal wires, and contacts on the switch. When I use the remote relay the way I do for the remote kill switch DIY, it is no longer capable of handling 250 amps. Because the ground connection is now coming from this tiny wire, this setup can only provide switching capabilities for low amperage circuits and only on the negative ground side. As we will see later, the wireless controller only pulls a maximum of 160 milliamps, so this shouldn't be a problem for these three small wires to handle. If I want to be able to switch a high current secondary circuit that isn't the battery, I would need to buy a remote relay that still has pin 85 available as a separate connection. This ensures that the wireless circuit and the switch circuit are isolated from each other, with the switch circuit having the proper components capable of handling a high current like the rated 250 amps. Next, I test the power usage of the wireless controller. When turned off, it uses less than 10 milliamps of power. Why does it still use power? Because the wireless controller needs to be powered so that you can still control it with the remote. Less than 10 milliamps is good. So even when people use this as a remote battery disconnect, the wireless circuit is always active and using less than 10 milliamps of power, even if the rest of the vehicle power is cut off. When turned on, it uses quite a bit more power at 160 milliamps. This is because the electromagnet is also being powered in order to close the switch. For a vehicle with an alternator, this usually isn't a problem as long as the vehicle is also turned on. This is because the car battery is being charged by the alternator too. If, on the other hand, this is used in a golf cart, leaving the remote controller in the on position while not being used or driven will drain more power from the battery just by sitting there. The same applies to using this in a vehicle with an alternator. If the remote switch is turned on when the vehicle is turned off, the wireless controller will still be using 160 milliamps of power while the battery is not being charged. For added safety, I add an inline fuse to the positive wire. It is quite long, and usually a positive wire connected directly to the battery should be fused as close to the battery as possible. To make things easier, I use these self-soldering heat shrink connectors to splice the inline fuse in. Lastly, the remote uses a CR2032 lithium battery, so have a mini screwdriver set and spare battery handy for when it needs to be replaced. We hope you found this video useful. Like and share with anyone else that could use it. Subscribe for more good stuff to come.